Okay, so let me give you a solid of revolution exercise. So here you've got a metal table and it's being heated. So this is a metal sphere. Down here is 80 degrees Celsius, up here is 50 degrees Celsius. There's a smooth transition from 80 to 50. So work out the average temperature. So remember, you've got to incorporate the volume and temperature into account. So you're summing up all the slices here. So remember, you're summing up all the slices, and you need to find out the temperature for this slice. You need to find out the temperature for this slice. You need to find out the temperature of this slice. Add up everything, and then divide it by its volume. That will then give you the average temperature. So find the average temperature of this sphere. So press pause and have a go. Okay, so to do this, we are going to translate our situation into a circle. So this is a grid, x-axis, y-axis. The equation of our radius of 10 is this. So this is the equation of a circle here. So we're moving. We're going to sum up everything. We're moving in the y direction. So it's going to be something dy. So our tracker will be our y. So this is our tracker. Suppose y is currently here. What is the radius of? Because we need to pi r square it to give us a disk. So we need to pi r squared the radius. But what is the radius? The radius here turns out to be the x value, because that's our x value here. So we're moving along in the y direction. So it's going to be something dy, and then our y tracker is here. Well, this radius here is given by us making x the subject. So it would be this 100 take away y squared square root. That will then give us this radius. And then once we've got our radius, we can pi r square it. So that would be this pi r. This is our r here. 100 take away y squared, and then we got to square it. So you're squaring a square root. So this is our pi r squared, and then you're squaring a square root. That would then give you this. So the volume is given by this, and I'm expecting you to know this by now. We've done this many times. So the volume of the sphere is given by this. But the thing is, we need to incorporate temperature. So as we're summing up all the disks, we know the area of the disk. But we need to find out the temperature of this disk for a given height, for a given y value. So for a given y value, we need to somehow find the temperature of this disk. Suppose y is up here. Suppose this is your tracker y. Suppose y is up here. Pi r square root will give us the area of the disk, but we need to find out the temperature of this thing for a given y. So the temperature is given by. So hang on. We need to develop a way of obtaining the temperature. And remember, it's a smooth transition from 80 to 50. So when y is negative 10, the temperature is 80, because look at this, hang on. So when y is negative 10, the temperature is 80. When y is positive 10, the temperature is 50. So from here to here, there will be a smooth transition. So to obtain the temperature, we need to, when y is negative 10, the temperature is 80. When y is positive 10, the temperature is 50. So anything in between, it will be a smooth transition. Well, this is a straight line. So any straight line, it will be y equals mx plus c. You see, if we can come up with the equation of this line, then we know the temperature at any given y. Suppose y is 2 here, then you know the temperature when y is 2. Meaning as you move up to 2, so suppose y is 2 here, then you have the ability to work out the temperature. and when y is 2? Well, the temperature is given by, this is a straight line, y equals mx plus c. We need to work out the gradient. Well, the gradient is given by the height divided by the base. The height is 30. The height is 30, and the width here is 20. And then it's going downhill, so stick a negative in front of it, and it's blah blah blah. This is high school stuff. So the temperature is the gradient is given by this, but remember Rx in this case Rx is our y. So the x-axis, this x-axis here is actually the height as we're moving. It's our, well, I hope you can understand. This x here becomes y. The y-axis on this thing here is temperature. So well, the equation is given by this. The temperature is given by this. So for any given y, for any given height, we have the ability to work out the temperature. So let me just summarize. I will continue in the next video. Okay.